Welcome to Maths with Bob. Today we're looking at the two volume techniques, slicing and shelling. And these are sort of, strange ones in some ways. The slices are fairly familiar from the volumes of solids of revolution. And the shells, or the cylindrical shells, are in fact a slightly new idea. And we're going to introduce a little bar, you'll see shortly. And basically, I always think of it like... just think of it like an onion. If you get an onion and you slice it, you get onion rings sometimes. And if you try and peel the onion, you can peel off layers by layers. It's like shelling. And basically, there are a couple of ideas about where we're going to put the bar. Now, the bar will need to be perpendicular or parallel to the axis, and this will become very important shortly. I'll just here we are. So I'm going to introduce this idea of inserting a bar into the area which we're going to rotate. And if the bar is actually perpendicular to the axis of rotation, then we create what's called a slice. And if it's actually parallel to the axis of rotation, it's a bit like a shelling or shelling idea. Okay, some people say it's a bit like, stirring a big pot with a big spoon or something like that. Or sometimes, as I said, the onion idea, the onion, shelling the onion, okay, or trying to peel an onion, if you imagine that. Okay, so the idea is that we're going to have a quick look at these ideas. We're going to create what's called volume seeds, and then we're going to actually form the actual volume by adding up these seeds, if you like, or adding up the slices or adding up the shells. Okay, now we are going to be looking in particular about this area here. You can see between y equals x cubed and y equals the square root of x. And you can see here I've actually inserted the bar. The bar is here. Okay, that's where the bar is. And the bar, you can see here, is actually perpendicular to the x-axis. It's always a good idea to think of it as having a thickness of, say, delta x if it's perpendicular to the x-axis, and if it's perpendicular to the y-axis, it'll have a width, say, delta y. Okay. Now, so we're going to first of all move this bar throughout that shape, and it's going from, you can see, 0 up to 1. There's a point of intersection of those two curves at 1, 1. Now, I'll just show you actually what I mean by that. Let's have a quick look. Here we are. Now, this is the bar. You might be able to see the bar CD. Now, the bar is actually placed between the two curves. Now, I'll just try and move it. Here we are. If I move it up and down, okay, let's try and move it. Here we go. You can see it gets thicker and thinner. It's a bit like a washer. This actually, when you rotate this bar around the x-axis, you can see it's got a bit of a hole in the middle there, and it's actually basically, as I move it through the shape, okay, it'll create lots and lots of different slices or washers, and we're going to add all these up to create the volume. So let's actually have a quick look now. I'll just try and put the animation on for the we'll put the trace. Okay, I'm going to put the trace on for the surface, and I'm just going to try and animate this. Okay, let's put the animation on. Okay, so this is now generating, okay, the volume by the slicing. Okay, so I'm moving it through, and actually I think it's going to oscillate backwards and forwards. But let's actually have a look at the different views. Oops, the view just disappeared then. Okay, I see, it doesn't like doing, that's interesting. Perhaps we should just rotate it around. Okay, maybe I'll just try and rotate it manually to show you what it looks like. Okay, here we are. Okay, good to go back home. Okay, so this is the shape we're going to be trying to find the volume of. Okay, all right. So I'll just stop a few things here. So stop the animation. Okay, so now let's go back to the. Okay, so this is what the shape we're going to try and find. Now we're going to. Okay, you can see here. This is basically what we're doing. We're putting that CD, that little bar, in between the two curves, and we're going to basically create what's called a volume seed. Now I'll call it delta V, which is a small change in the volume. Now you can see here, because it's a washer, we've got pi big R squared minus little r squared, and delta x. Now the bar's thickness is quite important when you start doing the integrations, because the delta x will obviously change to dx, and it'll also say that, well, we've got to use x bounds. Okay, so if you have a quick look there, that the volume is in fact the limit as delta x goes to 0, so we're going to shrink these eventually, but we're going to add them up with the Riemann sum, and then we're going to obviously take the limit, which is going to create the integral, and then we just have a quick look at the volume there. Now the volume, okay, so volume, okay, we're going to try and remember this because we're going to do it by shells and we should get the same answer obviously. Okay, so 5 pi on 14, and we're doing it by slicing around the x-axis. Now you can see here, okay, so we just sliced around the x-axis and created the volume. Okay, now if I want to slice it around the y-axis, okay, I'm going to have to obviously put the bar in now at a different orientation, you can say, if you like. It's how it has to be perpendicular to the y-axis. Okay, it'll have a thickness of delta y, and you can see the volume element will be in fact delta v equals pi r squared minus r squared. Well, now we're going to have them as functions of y as opposed to functions of x, and you can see here we're going to add them up as we rotate them around the y-axis, and I'll show you a little bit of a video of this, and this actually turns into 2 pi on 5 cubic units, you can see here, but the volumes are going to be different, okay, because in fact that area is not symmetrical. Okay, but we'll have a quick look now at creating the volume, or by slicing around the y. Well, okay, here we have now we've put the bar in. You might not be able to see it's AB now. It's going to have a thickness of delta y because it's actually going to be moving up the y-axis. Okay, now I'll just move the the washer, if you like. Just have a quick look. This is how it obviously moves through the shape. I'll just do it reasonably slowly. I'll put the trace on in a minute. We'll try and, if you like, generate the volume. Okay, so what I'll do, if I turn the trace on for the actual surface, okay, turn the trace on for the surface, and then I'll just move the surface, and it'll actually generate the volume. And I'll just move it back now. I'm just moving it through there we are. Okay, now let's have a look. It's a bit hard to see it, so let's actually have a quick look at this from maybe some different angles. Okay, just put it, okay, so you can see here it's now let's actually try and slow it down, so when you go around the corner you'll see that the actual, oops, let's move it back, you can actually see the individual slices actually. About there. Oh, okay, right, so they're the individual slices which are going to be added up, quite a lot of them, to form this shape. Okay, not such a great view from that particular angle, the home view, which I'll just put it back to the home view now. So this is the home view. Okay, so it's obviously a similar shape to the one before, not the same volume. If you go back and have a look, this was only 2 pi on 5 cubic units. Okay, so obviously they're not, I mean the area is not symmetrical, and this is why the two volumes are going to be different. But we're going to now have a look at, start having a look at shells. Okay, well, just before we go on to shelling, I just want to show you what the difference is. Obviously the bar orientation will now need to be parallel to the axis of rotation. Okay, but basically you can see here shells around the x-axis will be slices around the y, and shells around the y will be slices around the x. Now I'll just show you this on in Geogebra. You can see here now I've actually got slices around the y, but it's shells around the x. This is being generated from the same bar. If you have a quick look, obviously, okay, these are just showing you this, that the slice around the y, and the, if you you're shelling around the x-axis at the moment. Okay. All right. Now, well, okay, we're just having a look now at the orientation of the bar and how it impacts on the actual seeds, which actually are going to create the volume. Now, the first one diagram, you can see that the actual the bar, just see the bar. Okay, the bar is in fact, you can see it perpendicular to the y-axis or parallel to the x-axis. Now, as you can imagine, if I go around the x-axis, I create a shell or scribe out a shell. If I go around the y-axis, it makes a slice. Okay, and obviously these will be two different volumes, but their widths, the width of the bar in both cases, you can see here's delta y, and I've changed the diagram to actually put the bars. If you look down there, the bar delta y in both cases. Now, if you go to the next diagram, which is over here, okay, you can see here now, this is where our bar is. Our bar is now CD, and it's actually, you can see, perpendicular to the x-axis or parallel to the y-axis. Now, in both cases, its thickness, okay, is delta x, okay, because I'm going to be moving it through the shape along the x direction, I guess you could say, and it'll make a slice around the x-axis, okay, and a shell around the y-axis, okay. But in both cases, its thickness is delta x, and obviously, again, two different volumes. But this is quite important to realize that obviously the orientation of the bar is important, and depending on whether I'm slicing or shelling, okay, it'll create, if you like, the thickness, I guess you could say, of the bar. Okay, well, let's just have a quick look at the idea of a shell. Well, you can see here the shell obviously has a length, which is the circumference, okay, of the cylindrical shell. The height is actually the length of the bar, and the thickness is actually the thickness of the bar. Okay, so when we sort of like flatten out one of these shells, it turns into a rectangular prism, you can see here. Okay, and this is what will help us generate the seed for the volume element. Okay. Well, okay, let's start shelling. Okay, now you can see here we've got a little bar, which is black AB. It's been inserted, and now it's going to be rotated around the x-axis. So it's actually parallel to the x-axis, okay, as for shelling. And you can see here we're forming a blue cylinder. Now, obviously this the width is actually, you can see here, because the bar is actually moving up the y-axis, it's going to be delta y, and the y bounds are obviously 0 to 1, as are the x bounds in this case, okay. But because we're moving it through the area from 0 to 1 up the y-axis, its bounds are y and its thickness is delta y. This helps us generate the volume seed, obviously. Now the volume seed is just 2 pi r h delta y. Okay, remember this is a rectangular prism, okay, which has a length, if you like, a circumference, which is 2 pi r h. Well, 2 pi r, I guess, is the circumference, and the h is actually the height, which is the length of the bar, which we need to put in terms of y, because we're, the y variable is now relevant. And the one thing we need to have a quick look at is the radius. What is the radius? Well, the radius is actually where that bar is. It's traveling around. In this case, it's traveling around the x-axis. So it's actually its radius is y, and we need to plug all these in and create the volume element. And then you can see here that we get 5 pi on 14 as before. But we're now going to go through, and I'll show you how this is done in Geogebra. Okay, well, we can see here we've now created the shell. It's the surface, and I'll just quickly, just slowly move it up just to show you these are the shells we're going to be creating. Okay, there we are. They're the shells, and I'll just put the animation of the surface on. Well, actually not the animation, the trace. Actually, it's going to be the trace of the surface, and I'm going to try and scribe out the actual shape. Here we go. All right. Okay. Now, if I start to rotate this, let's actually try and rotate this and have a look. Okay, here we go. Ooh, now, if we look at it from this angle, you can actually see the, well, that's actually the shells there. Okay, and here we go. Just having a quick look. We have a bit of a red flash here and there. I don't know what that is, but oops, let's go back to home. Oops, no. Not right. Okay, well let's try and generate the shape by shells. You can see here by the shell. Just move the shell up and down just to show you. These are the shells we're creating. Okay, there we go. These are the shells. Now if I put the trace on for the surface, and we'll just move the surface backwards and forwards a little bit just to try and scribe out the shape. Here we go. Right, now we need to now have a quick look at this. So we're going to have a quick look. I'll just try and show you the shells. You can actually see the shells individually this way. Okay, right, here we are. This is the shape we're looking at. It's well, obviously like before, it's some sort of little dishy type looking thing actually. Okay, alright, try and send it home. Here we go, let's send it home. Okay, alright. Well, okay, you can see, okay, we've just generated that shape, and it has a volume of 5 pi and 14 as before. Now let's try and do, okay, the last little bit, which is the shells around the Y, and you can see here we've got a black CD and creating a purple shell, and when we add these up, we are going to get 2 pi on 5 as before as well. But you can see here is slightly different. The radius is now x, okay, the distance out, that bar is out from the y-axis, which is x. Okay, it's now, remember, its width would be actually delta x. It's moving from 0 to 1, therefore we need our functions as functions of x's. We need to put it into the formula, take the limiting value of this sum and turning it into an integral, and we should get 2 pi on 5 as before. But now let's go and do this in GeoGebra. Okay, here we have the shell around the y-axis. Let's actually just move it just to show you a little bit. Here we are. Here's the shell. There we are. Now let's just turn on the let's turn the trace, and let's actually try and scribe out this shape. Here we go. Oops. There we are. And let's actually have a quick look at it. Here we go. Ooh. I was a bit rough with my shells there. You can see I actually did it fairly quickly. But as you can imagine, when we do this, let's actually try and get that a little bit smoother. There we are, smoothing it off just a little bit. Okay, all right. Because that did look kind of rough there, so I'll just have a quick look. Here we go. This is a bit better, a bit smoother. There we are. Okay. Thank you for watching. Bye for now.